Hello, welcome to C1 warm up 2. So I'm going to start off with completing the square, or basically finding the max or min using completing the square. Now it's really easy this if you get the gist of it. If I am finding the so this is going to look like that vaguely, so I'm finding the maximum this time. Now the maximum is going to be 3, okay, because you're going to be always taking away a positive number. So the max is 3. And the max is always the bit away from the square. And the max is 3 when this bracket is 0. So when x is 2. So the max occurs of the function above at 2, 3. By the same token, if I'm finding the minimum of this, because it's a U shape, so it'll have a minimum rather than the maximum, the min is minus 4. And it's when the bracket is 0, so x plus 1 is 0, so minus 1. So the minimum occurs at minus 1, minus 4. Now if I then go to drawing some cubics for you guys. So if I'm drawing this, all I do to start off with is x is 0. So for x is 0, y will be minus 1 times minus 2, which is 2. So I can plot, when I start plotting in a minute, 0, 2. And when y is 0, x is just 1, minus 1, or 2. So what I can plot here is I can plot at minus 1. And make sure you label your points, guys. At 1, and at 2, and up here at 2. So I know that it must join up like so, but I don't know where it goes for the rest of it. So over here I can try x is 3, and when x is 3, y is just 2 times 3, so 2 times 4 times 1, which is 8. So when x is 3, try a number, it's positive, so it goes back up here. Now if I try 1.5, I know that 1.5 minus 1 is a positive, 1.5 plus 1 is a positive, but 1.5 minus 2 is a negative. So when I try a number between 1 and 2, it goes below the x-axis. Oh, look at a lovely graph there. Now a tougher one at this stage is y equals x squared 1 minus x. Okay. Now when x is 0, y is just 0 when I put 0 in, but when y is 0, x is either 0 from x squared or x is 1 from the 1 minus x. So I plot it. When x is 0, y is 0. Okay, and you plot 1, 0 as well. So it's only got 2 points that it goes through, so I have to be really careful with looking at where I go through, where I go above and below. So I'm going to start with a negative. So when x is a negative, minus 1, for example, minus 1 squared is positive. 1 minus minus 1 is also positive. So positive times positive is positive, so it means we go above here. Now when I try a half here, a half squared is positive, 1 minus a half is positive, so it must also go above again there. And when I try x is 2, 2 squared is positive, for 1 minus 2 is minus 1. So positive times negative is negative, and our graph looks like so. Right, the next set of graphs that I'm going to do here is just y equals 1 over x, y equals 3 over x, and y equals minus 3 over x. Now we should all know that 1 over x, what's that? With the asymptotes at the axes. 3 over x is just basically vertical stretch scale factor 3, so they get closer to each other, like so, but they still have the same asymptotes, guys. And the same over here. So like so. And minus 3 over x. So you might want to label points on that one, guys. So you've got 1, 3, and minus 1, minus 3. Okay, and y equals minus 3 over x, you just upside down it. So you've got minus 1, 3 here, and 1 minus 3. So it's a reflection in the x-axis. Now, something that a lot of people still don't do right is factorising using the AC method. So I'm going to do 3x squared minus 7x plus 2. So A is 3, B is minus 7, C is 2. So AC is 6 and B is minus 7. Now what you do in the AC method is you find the factor pair of AC which adds to B. Okay, now that will be in this case minus 6 and minus 1. Because minus 6 add minus 1 is minus 7. And minus 6 times minus 1 is 6. And you do smallest first. And then I rewrite the middle bit with those two numbers in the middle. I then factorise halfway. So you get 3x, x minus 2. Okay. And then the second bit you need to factorise. But you need the same bracket as before. So it's going to be minus x minus 2. So minus 1 lot of x minus 2. So I get 3x minus 1 lots of x minus 2. Now the last one that I'm going to do is a proof of the arithmetic series sum. So half n 2a plus n minus 1d. Now a quick thing to remember is forwards, backwards, add, factorise. Okay, so you write forwards, write backwards, add them and factorise. So I write forwards, a plus m plus d plus blah 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 plus the last two, which is a plus m minus 2d plus a plus m minus 1d. So I know that forwards you get Sn equals a plus d plus right up to a plus n minus 1d. Now backwards I get a plus n minus 1d plus a plus n minus 2d right up to a plus d plus a. If I add them now, I get 2Sn equals basically n lots of 2a plus n minus 1d. Because I'm doing 2a plus n minus 1d, as you can see, that plus that is 2a plus n minus 1d, but I'm doing n times, so n terms. Okay, and to finish off, I factorise.